Welcome, ladies and gentlemen. Today I will be talking about differential equations and how to solve them. Today I'm going to be talking about the separation of variables method to solve a differential equation using this technique. Here we are given the following differential equation. dy dx is equal to 2x squared plus 5 divided by 3y squared. We are given the initial condition of f of negative 3 equals negative 2. What that really means is x is equal to negative 3 and y is equal to negative 2. This will be helpful for finding the particular solution to this differential equation. And we're going to want to separate the variables, so we want variables on one side. So we want the y's on one side and we want the x's on one side, so we're going to multiply both sides by 3y squared. The 3y squared will cancel out. And then we're going to multiply both sides by dx. So the dx will cancel out on this side and will be on this side. So here's what we are doing for the separation of variables. Once we have the variables separated, we can now integrate. So now that we can integrate, we will integrate both sides. And we integrated a definite integral, an indefinite integral. An indefinite integral leaves us with a constant. We don't know what that constant is, but since we're given this initial condition, this point, we can find out what this particular solution is with this initial condition. So we're given this general solution, and now we will solve for c with our initial condition right here. Solve for c. Y cubed is equal to 2/3 x cubed plus 5x plus c. We're going to plug in negative 2 for y and negative 3 for x. And we find that we plug it in, and we find that c is going to be equal to positive 25. And then we're going to plug back c into the solution, to the general solution, and we get y is equal to cubed is equal to 2/3 x cubed plus 5x plus 25. And if you take the cubed root of y, you should get y equals the cubed root of 2/3 x cubed plus 5x plus 25.